Why do decision trees overfit? Imagine trying to solve a puzzle where every tiny piece, even the smallest speck of dust, influences the final picture. That's what decision trees do when they overfit. They get so focused on the training data that they start to memorize every little detail, including noise and outliers. When a decision tree becomes too complex, it creates very specific rules that fit the training data perfectly. But these rules often don't work well on new data because they are too tailored to the quirks of the original set. One reason for overfitting is that the tree keeps growing deeper and adding more branches. Each split tries to separate the data even further, but after a point, it's just capturing random fluctuations instead of real patterns. Think of it like trying to memorize every answer in a test instead of understanding the subject. The tree might split on a feature that is just a coincidence or a mistake, which leads to rules that only apply to the training examples. These rules are overly specific and don't hold up outside the original data. Another cause is that sometimes the algorithm gives too much importance to features that seem predictive in the training set but are actually irrelevant. This can happen if the data has noise or errors. The tree then makes decisions based on these misleading features, which makes it overly sensitive to small changes. Small datasets can also cause overfitting because the tree might learn the peculiarities of a limited sample rather than the overall trend. Without constraints, like limiting how deep the tree can grow or how many samples are needed to split, the tree can keep expanding endlessly. This unchecked growth makes the model overly complex and prone to overfitting. To fix this, techniques like pruning are used. Pruning involves growing the tree fully and then cutting back parts that don't improve accuracy. This simplifies the model and helps it better generalize to new data. In machine learning, decision trees are popular because they are easy to understand and work well for many tasks. But overfitting is a common challenge. If the tree is too complex, it will perform poorly on unseen data, which defeats the purpose of building a predictive model. Managing overfitting by setting limits on the tree's growth or using ensemble methods like random forests helps produce more reliable results. Understanding why decision trees overfit helps us build better models. When we control their complexity, we make sure they learn the true patterns rather than just memorizing the noise. This is key to creating AI systems that are fair, accurate, and trustworthy.